So we're going to talk about sets and intervals today. And I have a bunch of sets written here. And as you can see, there are different ways of representing. We're going to talk about these. And so in our first example, we have A is equal to, and I have in brackets or braces, 1, 2, and 3. So the set A is defined to be the set containing the numbers 1, 2, and 3. We could say that 2 belongs to this set by writing 2, and then this funny looking E that's actually a Greek letter epsilon. So we could say that 2 belongs to the set A. So 2 is an element of, and that actually stands for element. So it's one word that you might hear from time to time. I'm defining the set B as the set containing 2, 4, 6. I have a comma and 3 dots. Those dots are called ellipses. That means that the pattern continues, and it's a set of all even numbers. So sometimes we have sets that are what we call finite sets, which contain just a finite number of elements, which means we can list them all. And we have other sets that contain an infinite number of elements. And we have a pattern that we can establish. And once we establish that pattern, we can use these ellipses to suggest that that continues on. I could not write all those numbers. There's an infinite number of numbers there. We also have some fancy letters that we use to represent special sets that get referred to all the time. And this is what we call a double struck N. And a lot of times you'll see it written like this, where it just looks like the word in, but the bar next to the N is actually really close if you see it typed. But I try to make sure it was obvious one character here. So the natural numbers is what this is represented by the double struct N, and it's a set containing all the counting numbers 1, 2, 3, and so forth. I have this fancy double struct Z. This represents the set of the integers, which are all the positive, negative whole numbers. And so I have patterns going to the left and patterns going to the right here to illustrate that it goes both directions infinitely or indefinitely. The reason why we're using a Z here is because Germans were doing a lot with math a few hundred years ago, and the German word for count would be Zahlen, and so that is why that is used there. We could write the set of whole numbers. Some people would write a double struct W, and you can say that is the natural numbers plus the set containing 0, which is a fancy way of writing things. We're not going to use that too much here. In fact, we're not going to use a lot of these too much in this class. You see them in future classes a lot, so I'm letting you know that they exist. I have the set Q, and I have this really crazy contraption written here. So let's talk about what this means. This is actually the set of the rational numbers. So this is all the fractions. It's a formal way of writing what a fraction is. And that is m divided by n, such that m and n are integers and n cannot be 0. And this contraption right here is really important. We're going to see it a lot in this class. And this is set builder notation. And what this is this is just a fancy way of writing. Well, if I see curly brackets or braces, that means I'm looking at a set. This m over n contraption, so whatever you see on the left-hand side of the bar, sometimes it's 2 dots, but I use a bar. That's the set of what we're looking at. And a lot of times it's going to be a variable of some sort. In this case, it's 2 variables, one divided by another. And I'm saying that these 2 variables belong to the set that we defined above. And I'm saying that the denominator of this fraction cannot be 0. So it's all the fractions that are made up of integers, one divided by the other. So again, this is stuff that we're going to see in our future for math, and they might pop up from time to time, either in the book or in particular lessons. We're not going to see these fancy things too much just yet, but they do show up a lot. And if you're going to watch somebody else's videos, they might use them more than I do in this series. So that is a crash course on what sets are. Let's look at some some fancy sets. We're going to talk about things called intervals. Intervals are special sets that contain an infinite number of numbers, and we use a number line or inequalities to represent them. So if I were to say x is less than 2, that would mean all the numbers that are less than 2. And if we stop and think about it, there's a crazy amount. There's 1, there's 0, there's a half, there's 3 halves, and then there's all the negative numbers and all the decimals and all the fractions that we could think of. And so when I talk about the set x is less than 2, it's actually easier to think about a number line. And then we think about where 2 is on the number line. And we usually, in this class, I'm not going to always put 0 in, but for right now, I'm going to put it in as a marker. So 2 is to the right of 0. And if I want numbers that are less than 0, I'm thinking about everything to the left. Everything to the left of 2. So it'd be 0, that would be 1, that would be negative 5 halves, negative pi, and it goes on indefinitely. So I'm allowed to get as close as I want to 2 in this case, but I'm not allowed to attain that value 2. So what we do is we use either a round parenthesis, opening up in the direction that we're concerned about, or we use an open circle. And lately I've been using the round parenthesis because that shows up a lot more in some software packages like Hawks or WebAssign. But either way, we can, those are interchangeable. So this is saying the set of all numbers such that x is less than 2. I could put that in this thing called set builder notation. I'm looking at numbers x, and then I have a rule that says x is less than 2. So that's a set builder version of writing that interval. And it's an infinite number of numbers. So it's contained everything on that number line. So any number, 2 numbers I could think of, and then numbers in between those, and we can keep going. There's a more compact way of writing this, and that's with interval notation. And so that is the set that goes up to 2, but doesn't get to 2. So I'm going to use that round parenthesis thing, and that's another reason why I like that. And it goes on indefinitely. So I'm going to use the infinity symbol, but since it's going to the left, I'm going to put a negative in front of it. So this is the interval of negative infinity to 2. And that's how I write, well, these are all the same thing here. I'm saying x is less than 2. That's an inequality form. This is a number line or a graph. We have the set builder notation. I'm going to write that again. And then we have the interval notation, which is negative infinity to 2. And we're not including the number 2. So what happens if we're allowed to have the number 2? So let's say x is less than 2. My graph would look very similar. I'm not going to bother with 0. I'm just going to put 2 there, but I'm going to put a square bracket. And I'm shading everything to the left. Again. And in set builder notation, x such that x is less than or equal to 2. And in my interval notation, it's going to be negative infinity to 2 again, except I'm going to close it off with a square bracket after the 2. So the square bracket means that we're including the round parenthesis means we're not. You're going to notice that I'm always going to have a round parenthesis around infinity or negative infinity. We never include infinity or negative infinity. Infinity is a concept, it's not a number. So you can never attain the value. So similarly, if I were to look at something in the form of x is bigger than or equal to some number a, we could also write that as a is less than or equal to x. So either way, it's equivalent. We got to just remember that the inequality sign opens up the same direction. So it's opening up toward x here, it's opening up toward x here, and that's what we mean by direction. It's opening up toward the same variable or number, so forth. So I don't know where a is on the number line, because I don't know what kind of number it is, but I'm just going to say, well, it's here. That's my number a. And since I want numbers that are bigger than a, I'm going to shade to the right of it. And since I have an inequality that is non-strict, that's inclusive, I'm going to use a square bracket. And that's how I'd graph that. So that would be a to infinity. So just a note, I said the open circle is non-inclusive. So that's a strict inequality. We have a similar idea, and that would be a solid dot. So you can use those two on when you're hand graphing things on paper. If I want to set builder notation, that would be x such that x is bigger than a, bigger or equal to. Or you can write the a is less than or equal to x, whatever you prefer. If I were to have a non-strict inequality, I'd use a round parenthesis, and I'd get rid of the bar underneath the equal sign. And that's how I'd write those. Then there's another type of interval, and that's one that has endpoints on both ends. So a serves as an endpoint on this interval, and it goes off indefinitely. And on those above, 2 served as the endpoint, and it went off to the left indefinitely. So if I had what's called a compound inequality, a is less than x is less than or equal to b. I have a number line, and since a should be to the left of b based on the direction of how things are, I am going to write a on the left of my number line, b on the right. And what I'm going to do is I'm going to shade everything in between. And I got to figure out how to terminate things. And since a is a strict inequality, I'm going to use a round parenthesis. And if b, since b is a non-strict inequality, I'm going to use a square bracket. And again, I like this interval or this parenthesis bracket notation because that tells me what my interval should look like. That's going to be a to b. Be really careful with how that looks. Make sure it's clear. And so I have my interval from a to b. And the square brackets, round parentheses are determined by the inequality signs. Or if we're given an interval notation or a graph, the inequality signs are determined by how things are terminated. So real quick, I want to talk about some things that we shouldn't do. And this is especially true with, well, this first one's with compound inequality since we're here. A lot of times I'll see this, a is less than x less than or equal to b, and this is bad. We can't do that. It doesn't make sense to have the inequality signs facing in different directions. They need to be pointing the same way. So if one part of a compound inequality is opening to the right, the other part should be also opening to the right. We also don't write things like -2 is less than x is less than -3. because this is not true, because -3 actually belongs on the other side. -3 is less than x. And again, switching the inequality sign you might say, well, that makes it make more sense, but it really doesn't. We want the inequality signs facing the same way. I already said that we never include infinity. So this doesn't make sense. If I'm going from -infinity to infinity, which actually we need to talk about that. That's a special case here. We don't include infinity, so that should be round parentheses. And just so you know, this is the entire real line. And if I were to draw it, I would shade the whole thing. The whole thing would be shaded. I wouldn't have any points highlighted. I don't need any points highlighted. It's the whole thing. We actually have a special symbol for that. And that's the set of real numbers. Double struck R, X, such that -infinity is less than X is less than infinity. Because we can't include infinity, we should never see less than or equal to signs. And so that is another special set that we're going to see. Actually, we're going to see this one a lot in this class. Some other things. We should never see infinity to 2, even if we're not including it, because it doesn't make sense that infinity is less than 2. So our intervals need to read from left to right. So the smaller number or more negative number needs to be on the left, and the larger number or less negative number needs to be on the right. And when it comes to infinities, well, -infinity should be on the left all the time. Infinity should always be on the right. So this is another thing that's a no-no. And in the next video, we're going to talk about some operations between sets, and then we're going to use these to talk about solving inequalities.